Hey mathematicians, this is Mrs. Shopper coming back to you with day 2 of chapter 4. We're talking about angles of triangles. Continue to look for those note card symbols so that you're making sure that you're getting those topics into your note cards. At the end of the unit, you will be taking a picture of all of your note cards, kind of like scattering them on your table, taking a picture, showing me them, and going from there. So again, we talked about in class in our Google Meet on Tuesday how to do that. So make sure you're referring back to that. All right, here we go. So we have our first theorem. It's called the triangle angle sum theorem. It shows you something that you've already known, that the sum of all the measures of an angle in a triangle is 180 degrees. It's a theorem, meaning it's been proven, and it's something that you've practiced in the past. An auxiliary line, we talk about them minimally, but they do come up. It's an extra line or segment that you put in a figure to help analyze it. And we'll show you examples of that as needed, but just so you know that when you're given a picture and you're trying to analyze it, sometimes that extra line segment does help out. Okay, so when we're looking at this particular diagram, it shows the path of a softball through a softball drill, okay? And we have angle measurements listed there. We need to find the missing measurements. So what we know is that the sum of all the angles in a triangle is 180. So the measurement of angle 1 plus 43 plus 74 is going to equal 180. And then, so if we simplify that, the measurement of angle 1 plus 117 equals 180. So the measurement of angle 1 is equal to 63 degrees. Okay, subtract 117 from both sides. So the measurement of angle 1 is equal to 63 degrees. Because we know that angle 1 and angle 2 are what we call vertical angles, we can use the vertical angles theorem that we learned in first quarter to state that angle 1 and angle 2 are the same measurement. So we can then say that the measurement of angle 2 is also equal to 63 degrees. And then to find the measurement of angle 3, we're going to substitute that in. So we have the measurement of angle 3 plus 63 plus 79 equals 180 degrees. So the measurement of angle 3 plus 142 is equal to 180. So the measurement of angle 3 is equal to 38 degrees. All right, so in this case, the arrows show the path. They are not showing that anything is like parallel. Okay, so they're just showing the path of the ball. So the measurement of angle 3 is 38 degrees. And then the measurement of angles 1 and 2 are 63 degrees. So using that triangle angle sum theorem to help us find the missing angle measurements, and then also referring back to what we learned in first quarter about vertical angles. Again, anything we learned in first quarter is fair game for anything we do this quarter. So everything builds. We anticipate and we expect that you remember, you've retained what those mean. Feel free to look back at your toolbooks. If those are being filled out well, those will be a huge resource for you. So you don't have to like dig through pages and pages of work, but that should be really helpful for you. All right, so what I'd like you to do is pause the video and find the measurement of angle 3 in this problem. Pause the video. Great, thank you. All right, so when I look at this, welcome back. We know that 38 plus 67 plus the measurement of angle 1 is equal to 180 degrees. We know that 105 plus the measurement of angle 1 equals 180 degrees. So the measurement of angle 1 is 75 degrees. Because angle 1 and angle 2 are vertical angles, we use the vertical angles theorem to state that they're the exact same measurement. So the measurement of angle 2 is also equal to 75 degrees. And then we can say that the measurement of angle 3 plus the 75, actually, because we know that measurement, plus 48 is equal to 180. So the measurement of angle 3 is equal to 113 rather 123. Equals 180. So then the measurement of angle 3 is equal to 57 degrees. Measurement of angle 3 is 57 degrees. A new theorem that you might not have heard about prior to this is called the exterior angle theorem. Notice the note card in the upper right-hand corner. It's a bit of a delay. The exterior angle theorem says that an angle on the exterior, such as number 1, is equal to the sum of the two remote interior angles. Now, because it's a theorem, that means we can prove it. The reason why this works, can you guess it? Can you think of it? Why do you think that would work? We're thinking, okay. These two angles right here are supplementary because of the supplements theorem, right? They form a linear, they're adjacent linear pairs or linear pair, and so they equal 180. Well, if these two equal 180, and then the sum of this one, and this one equal 180, algebraically, we can say that this exterior angle is equal to the sum of the two remote interior angles. Okay. Note card, make sure you get it on a note card. Exterior angle theorem. Right. So here we go. We're going to find the measure of angle FLW. That's this angle right here, shown in this picture. So we know that this angle, the measurement of angle FLW, is equal to the measurement of angle, or measurement of O, measurement of angle O, plus the measurement of angle W. So I'm going to fill in what I know. 2x minus 48 is equal to x plus 32. So now I have an algebraic equation that I can solve to figure it out. So x is equal to 80. So now I know what x is. Now I'm going to substitute that in to solve. So 2 times 80 minus 48. So 160 minus 48 is 112 degrees. That's the measurement of angle FLW. All right, triangle angle sum corollaries. So a corollary is a theorem with proof that's really the direct result of another proof. Okay, so this one builds from the right angle theorem, and so the acute angles of a right triangle are complementary. That's our first one. And then there can be at most one right or obtuse angle in a triangle. Now, when we label our reasonings, we don't ever use like 4.1, 4.2, 8.7, because those numbers are specific to our textbook. So it is the first corollary in chapter 4, and it is the second corollary in chapter 4. So we don't use those numbers. We have to make sure we give them a name. Okay, so the acute angles of a right triangle are complementary. That is one corollary. The other triangle sum corollary is that at most you can have one right or obtuse triangle. So I'm going to give you some time to work. If you want to pause the video to find the measurements of 1, 2, 3, 4, and 5, make sure you're showing your work. I want to make sure I see your steps, especially since we're not in person and I can't kind of look over your shoulder and see what work you're doing. It's important to me that I can see your process. And so I want to make sure you can do that. So when I'm looking at this, I think the first one I'm going to look for is actually 5. And so I'm going to say that the measurement of angle 5 plus 41 plus 90 equals 180. Again, this is my symbol for 90 degrees. So the measurement of angle 5 plus 131 equals 180. And the measurement of angle 5 is equal to 49. So this is 49 degrees. I also could have used the corollary and said that 5 plus 41 equals 90. That would have been another way to do it. So measurement of angle 5 is 49 degrees. When I look at maybe trying to find 3 next, I know that 48 plus 90 plus the measurement of angle 3 is equal to 180. And so 138 plus the measurement of angle 3 equals 180. So the measurement of angle 3 is equal to 42. So 42. So I'm kind of just jumping all over with how I'm doing this. No one says you have to do it in a certain order. I do know that 1 is an exterior angle, and 48 and 56 are the remote interior angles. And I know that the sum of those two is equal to the measurement of angle 1. So the measurement of angle 1 would be 48 plus 56, which would be 104 degrees. Okay, so I'm going to take 48 plus 56. I know that 1 and 2 are supplementary because they're a linear pair, and the supplements theorem says that they equal 180. So I want to make sure I'm justifying every step of the way to make sure I'm utilizing some of that vocabulary from either the year. And we can't just say it looks like. We have to give proof for everything we're doing. That's what we're doing in geometry this year. We're trying to prove every step we make, to not just be like, I think that's it, or it kind of looks like it. We have to give it some good solid proof. So if the measurement of 1 is 104, then the measurement of 2 is going to be 76 degrees, because 104 plus 76 is 180. Okay. And then I'm looking at number 4. And with number 4, the measurement of angle 4 is equal to 76 degrees. Ooh, I need to figure out what this measurement is right there. So 34, or 90 minus 34 is going to give me 56 degrees. So plus 56, let's change this to a plus, equals 180. So I'm showing all of these steps. And I know for some of you are like, I want to do this in my head. I get it. And I'm an awful mind reader. So I really need your help with making sure that we get this down on paper. So the measurement of angle 4 plus 76 plus 56 is 132 is equal to 180. So the measurement of angle 4 is equal to 48 degrees. All right. So being able to show your process, it's kind of a little scattered. That's okay. I've shown where my answers are, kind of line them up neatly, and then I have all my supporting work around it. So what you're going to be working on today is on page 250. Keeping in mind that when you submit your assignment, it needs to be scored. You need to mark each problem as either right or wrong, and you have to put your score at the top of the page so I can see that. If you want to earn credit, you need to do that follow through to ensure that we're understanding what we're doing. All right. Any questions? Send them my way. Enjoy your day.